Knowing the location of the poles and the zeros of the transfer function h of s is also very useful to approximate the frequency response h of omega of the system. For this, first remember the relationship between the transfer function of the system h of s, where s is a complex variable with a real part and imaginary part, and the frequency response h of omega. When setting s equal to j omega, so replacing the complex variable s with a purely imaginary value j omega, yields the frequency response h of omega, which is also sometimes written as h of j omega to make the connection between the transfer function h of s more obvious, since s is replaced with j omega. H of s is a function of the complex variable s, which has a real part and an imaginary part. So h of s is not defined on a line, but on the entire complex surface. We know that h of s is equal to infinity at the poles, which we symbolize with crosses. We also know that h of s is equal to 0 for all values of s which are 0, such that the numerator of h of s is equal to 0. And in a pole zero plot, the zeros are symbolized with little circles. When we're interested in the frequency response, what we have to do is to evaluate h of s not on the entire surface for the complex variable s, but along the line for s equals j omega. This is, along the imaginary axis. To approximate the shape of the frequency response, we will imagine the s-plane to be a tent ground. For any location of a pole, we know that h of s goes to infinity. Hence, we imagine here to be an infinite pole that draws the tent up. And for the zeros, h of s is equal to 0, so we imagine the zeros to be the locations of nails which hold the fabric down to the ground. Imagining now h of s to be the fabric of the tent in between the poles and the zeros will help us to imagine the shape of h of s. And drawing the shape of the imaginary tent fabric along the imaginary axis will give an approximation of the frequency response. For this example here, it might look like the following. Where for omega equals 0, the frequency response increases slightly due to the pole directly behind the imaginary axis, and where close to the zeros, the frequency response decreases and goes closer to 0 because it's near the imaginary nails or zeros of the system. This plot here shows the 10-plot approximation of a system with 4 poles and 4 zeros, of which we see only 2 in this plot. The plot is drawn in a slightly different angle, where this is the imaginary axis, and the magnitude of h of omega is given in dB, that is, in logarithmic scale. The system has 4 poles for which h of s goes to infinity, and hence h of omega takes a higher value close to those poles. The system also has zeros, for which the frequency response is dragged down closer to 0.